Welcome, Leandro and Diego.
Thank you. Um, so we are Leandro Mainers and Diego Sor. We both work at Core Security Technologies Consulting Services. Mainly we do pen testing and source code auditing there. So basically based on that, we did our research and we are researching all the time based on what we see out there. So enjoy the talk and let's start. So first of all, an agenda for this talk. We are going to review or to reintroduce some of the concepts of web. Then we are going to introduce WPA migration mode, which is the main topic of this talk. Then we are going to talk about the attacks, how to attack the WPA migration mode, and some mitigations and recommendations in order to avoid or to prevent these attacks to happen. So basically, this is the agenda for the talk. So web, we all know, or probably, yeah, we all know that is broken. At this point, we know that it shouldn't be used. But well, anyway, we are going to review some of the key concepts that are the building blocks of our attack. So web was meant to provide confidentiality, to provide access control and integrity over the packets we transmit. So web is based on RC4, which is a symmetric cipher, meaning that both endpoints know the key and the key is the same on both endpoints. And it is a stream cipher, which means that the encryption happens one digit at a time, so each digit is encrypted independently of the rest of the stream or the packet. Then it includes something they call the ICB, which is the CRC32 of the plain text message. This is the integrity check value, which is transmitted in order to ensure the integrity of the packet. And then for the key management, 802.11 does not provide any key management service. So web depends on the end user to distribute and to provide a secure way to distribute the keys. So generally the keys are statically set and configured somewhere in a file, in a configuration, web page, whatever, depending on the equipment. So this is the basic diagram of the web encapsulation. We have the plain text that goes through the CRC32 calculation. We concatenate the two, meaning the plain text and the CRC32. Then we have the initialization vector and the web key. We concatenate the two, and this is called the seed that enters the RC4 pseudo-random number generator, which is basically the RC4 generator of the key stream. So the key stream is the encryption material that we are going to XOR with the concatenation of the plain text and the ICB. So from there, we got the ciphertext. So basically, we have the key stream, we have the plain text message concatenated with the ICB, and we exclusive OR those things to obtain the ciphertext. Then we prepend the initialization vector. This is in order to the receiver to know the initialization vector that is used to decrypt the packet. So this is the basic diagram of the web encapsulation. So back in 2001, one of the first papers published about how to tamper a web message. What does it mean? So we can build a new message based on the old ciphertext that is still valid. So basically, one of the key elements for this to happen is that CRC32 is linear with respect of the XOR operation. This is the basic that we need for this to happen. So we claim that it is possible to build a new message, a new ciphertext, C2, based on the first ciphertext and a delta value that is arbitrarily selected by the attacker, and we can control it. So basically, knowing the ciphertext and setting a delta value, we can build a new ciphertext which is valid for web encapsulation. So in layman's terms, we have to sort the data with the mask delta. This is the arbitrary value the attacker uses and selects, and sort the ICV, meaning the CRC32 of the original message, with the ICV of the mask, meaning the ICV of delta, right? So having this in mind, we are going to show an attack based on these properties. So now a brief introduction to WPA. What is WPA? Basically, Cisco has in its 1200 AP series this kind of functionality that allows clients using web and WPA to connect to the same service set identifier, the SSID. So WPA clients capable of TKIP and authenticated key management can connect to this SSID. 802.1x clients, such as legacy lib clients and clients using TLS, but capable of authenticated key management, but not TKIP. This is called the dynamic web clients. And finally, web clients not capable of TKIP or authenticated key management. This is the old web client stuff, which is where the key is set manually. So using the same SSID, we can connect with either a WPA station or a web station. So this is how we can identify an AP working on this particular configuration. So we have the multicast cipher and we have the unicast cipher. We see that for the multicast cipher suite, the beacon shows that it is using the web 104 bits, and for the unicast cipher suite, it is using TKIP. So both ciphers are used on the same AP, and they are advertised in the beacon. So basically, we have both ciphers that we can use. So for multicast and broadcast, which is basically that we are going to show, we can use either web or WPA. So using web as a multicast cipher allows web and WPA stations to decrypt multicast traffic. So basically, this AP will use web for multicast and for broadcast, and for the stations that are only web stations. And we'll use WPA for unicast traffic that is for WPA or TKIP, in this case, stations, right? So the AP tracks which station is web and which station is WPA and forwards. Remember that 802 wireless or Wi-Fi in general is a switched network. So basically the AP forwards each packet to each station, taking in account the type of encryption the station is using. So if the station is using web, the unicast packet will go in web. If the station is using WPA, the unicast packet will go using TKIP. But for the multicast and broadcast packets, the IP will always use web. So this is the basic configuration for an IP working in this particular way. So WPA became optional from the Cisco's documentation. A cipher suite containing TKIP and 40-bit or 128-bit web configuration, and a static web key in key slot 2 or 3. This is one of the differences we find with the typical web configuration, because this is a requirement to put the key in slot 2 or 3. Then we have the capture of the terminal, where we configure the IP. So you see that the encryption mode ciphers are TKIP and web 128 bits. The encryption key is in slot 2, and the key is here, the SSID. And then you see the authentication key management as WPA optional, because this is a requirement for the IP to work. So how to detect this AP working? So basically, working in WPA migration mode. Basically, we are going to look for the beacon frames. So first of all, try to filter the beacon frames using the frame control type subtype field. Then that the beacon must, the WPA element must be present within the beacon. Then the multicast cipher suite, which is inside one tag of the WPA elements, must be multicast cipher suite web 40 bits or multicast cipher suite web 104 bits. And finally, the unicast cipher suite is TKIP. So unicast cipher suite, TKIP. So this is the basic element we have to look for when we are looking for an AP working in migration mode. So this is all the filter elements combined in one visualization filter and a Wireshark capture of the beacon frames. Then we have Kismet here, the tool for wireless information gathering, pen testing, whatever you want, that we patch in order to detect these APs working in migration mode as web APs in red, if you see on top of the image. Why? Because as the talk goes by, we are going to show that having an AP working in migration mode will pose the same risk as an AP working in web. So it is important to flag it as a web AP. In fact, this is not a web AP, but we are going to show that the risk is the same. So we see there the details of TKIP, cipher, web cipher, and we configure the AP in pre-share key because it was easier for us to test this, but you can use 802.1x or whatever. And then the details of the AP, the BSSID, the ciphers, and all this information that is shown in the capture. So now Leandro is going to talk about how to attack. So we present the migration mode, and Leandro is going to talk about how to attack these APs.
Okay. Hi, can everybody hear me? Okay, great. Okay, kicking off where Diego left off, I'm going to start talking about how to attack an IP configured in this manner. So basically, the first step is that when we bumped into this at a customer of ours, and something smelled fishy of having this hybrid configuration, so we started to see what we could do with it. So the first thing we did is we started looking and browsing through the documentation to see what we could find that Cisco was saying about this WPA migration mode. So basically what we found is that Cisco says that the security will operate at the least secure level common to all devices. So this basically split the scenarios into two possibilities. when you have web stations and when you don't have web stations, which are going to be the two cases that we're going to try to attack the AP under these two different scenarios, because they say that basically it's secure as the least secure common to all devices. So, okay, if we don't have web devices, this should be as secure as WPA. And we found that it doesn't matter if they're web devices or not, this is only as secure as web. So it's completely unnecessary. And, no, wait. And another thing that we found is that Cisco only acknowledged the possibility of doing a passive web key attack. What we're going to show is that you can do another types of attack, which are much more interesting. Basically, the first scenario, which is a trivial case, the easy case, is when there's still web stations hanging around. So in this case, what we have to do in order to crack the web key is we can do a standard attack that AirCrack implements. And what we do in this case is instead of attacking the AP, we attack a web station. As there are web stations using the network, we can just target one of those stations. And in this manner, we forget about how the AP is configured. It doesn't really matter for us because as we're attacking a station, the attack is completely oblivious of how the AP is configured. So basically what we do is we passively wait and sniff to find a broadcast ARP frame, which we can distinguish even though it's encrypted by its characteristic size. And as Diego mentioned, all broadcast traffic is encrypted with WEP, which is what all stations would understand. So basically what we do is we wait to see that type of frame, and we wait to see a frame that is answered by a web station. And we can see this by doing a little bit of traffic analysis and seeing when the station replies. So what we do is we capture that frame, and since WEP has no replay protection, we re-inject the same frame, sending it directly to the station. That's why we have to set it from the S bit, which means that the packet was coming from the AP. So the station would see the packet and say, okay, somebody's sending me a frame, it would decrypt it, and since it's a valid frame, it would be an ARP frame that we captured. The station's gonna reply, and each time the station replies, we capture that traffic, and that traffic will be valid web traffic sent by the station. So if we capture only that traffic, and we gather enough of that traffic, we can crack the web key under this scenario. This is a standard tool. AirReplay performs this attack in its standard configuration. Basically, the attack is using the -2 option of AirCrack. And below is the documentation on how to carry this out. So this basically is the trivial case. Now, we're going to go into the more interesting case when we assume that there are no longer any web stations connecting to the AP. So we only have WPA stations. And this was a scenario that we found at our customers because they had finished their migration, but they never turned off this feature. Everybody forgot about it, and they just left it on. Since they thought that they had all TKIP stations, they thought they were secure. So what we found is that we can still crack the web key. It takes just a little bit more, just a few more steps, but it's fairly easy. What we do is we first authenticate with the access point as a web station. This is very easy to do. We can use AirCrack for this first step. And since we authenticate as a web station, we don't have to prove knowledge of the key, as the web is configured in open authentication, and this is a requirement by Cisco in order for it to work in this mode. So we don't have to prove knowledge of the key. Then we wait and capture a broadcast ARP frame, which will be web encrypted as it's a broadcast frame. We bit flip it using what Diego described earlier about message tampering, and we do this in an intelligent way so that the ARP frame becomes an ARP frame from our station, because we know who sent the ARP frame, and we know our MAC address, and we know the source MAC address of the sender. So we can calculate a mask that even though we don't know the specific contents of the frame, we can build a mask that if we apply it to the frame, we can obtain a new frame which is also web encrypted and valid, but that is an ARP frame that as if we had sent it from our MAC address. So what will happen is that when we send this frame, we send it to the AP, and since we have authenticated as a web station, the AP does not have any trouble in getting that frame and forwarding it along because we are a web station, so we are allowed to send web traffic. So basically the AP sends it along. This frame that the AP sends is re-encrypted, is also encrypted with web, so we can use this frame for cryptanalysis purposes. So we have to be sure and capture these frames. And also, the station for which the original ARP was sent will reply. And once the station replies, the reply will be sent back to us by the AP, and it will be sent as a web frame since we are a web station. So therefore, we have for each frame we sent, we have 2 frames that are web encrypted and that can be used for cryptanalytic purposes. So then what we do is we run aircrack against it to obtain the web key. Basically, at the full URL below is our site for research, for Core Labs research. And you're going to see what we're going to demo. We made some patches to aircrack so that we can carry out this attack using aircrack. So basically, I'm going to go over this with a diagram because I'm pretty sure nobody understood before. So I'm trying to, this is the main focus of the talk, so I'm going to go over it again so that when we see the demo, everybody can follow it. Basically, the scenario is this one. We have 2 WPA stations, and we are the attacker. Then the station A sends a ARP frame, which is TKIP encrypted, because it's every time that a WPA station talks to the AP, even if it's sending broadcast traffic, it encrypts it with TKIP or IS if it's using WPA2. Because in WPA and WPA2, since everything has to go through the AP, stations never use the broadcast key to encrypt. They only use the unicast key to encrypt, and then the AP uses the broadcast key if it has to forward it along. So basically, this is sent in the air as a unicast frame, which the AP then re-encrypts as a web frame because the multicast cipher is web, and it's sent on the air. So this frame we can capture because it's a web frame that we need. Then the station B will see that frame, the ARP frame, and will say, okay, now I have to answer that. It will send a unicast reply encrypted with TKIP. This reply will be forwarded by the AP onto station A, and also TKIP encrypted using the key that the AP and station A share. And what we do as attackers is the frame that we had captured, we bit flip it to turn it into the same who has request for station B, but this time coming from our source MAC address. And then what will happen is that the AP will forward it. That frame is a new web encrypted frame, which we can use for cryptanalysis. And then station B will reply also in TKIP because it's a WPA station. But the AP will forward it to web to us because we are a web station and we have authenticated as a web station. So the AP tracks the encryption everybody's using, and he sends it along in the proper manner to us. So that's another frame we can use for cryptanalysis. So here, what I'm going to talk a little bit is that a similar attack to this one can be carried out without having to patch aircrack, but it has a few caveats that must be taken care of. The first few steps are the same, but what we do is, instead of bit flipping the frame, we just re-inject the same frame. And the problem that this has is that we're only going to have 1 frame sent per frame that we send because it's going to be what the AP forwards. And the other problem is that aircrack either expects the network to be WPA or expects the network to be web. So when we run the cryptanalytic process on it, if it detects the network as web and there are TKIP packets in the capture, what it will do is it will throw off the cryptanalysis because aircrack assumes that the whole network is web, because when the guys from aircrack programmed this, they didn't think that there was going to be the case where you had a mixture of TKIP and web traffic in the same AP. So basically, this can be done with aircrack, but you have to do it with interactive mode and looking at what you're doing. So basically, what we did is we automatized this, and what we also did was patch aircrack so that when it detected that it could filter out web traffic and TKIP traffic so that the cryptanalysis was not thrown off and that you don't have to filter the capture before running it in aircrack. So here I'm going to show a little demo. We have a video of what we did. So basically, the first step is I'm starting Wireshark in sniffer mode. And here I'm going to implement a filter which basically captures beacon frames from our AP so that we don't have a lot of trash going around in the air. Basically here I'm going to show that we have a beacon frame, and I'm going to show what Diego was talking about, how to detect it. We see that the SSID is migrate, which is what we set it to be, and that we are using that in the WPA information element, we have a cipher suite of web for the multicast cipher and a unicast cipher suite of TKIP for unicast traffic, and that we're using pre-shared key mode. We could be using 802.1x, just what is easier to set it up in this way. So now what we do is we show the same thing in our patched version of Kismet. As you can see, well, probably you can't because black background screws everything up, but it's marked in red, and it's detected as a WPA migration mode AP, which you can show here. And basically we added this capability to Aircrack to Kismet, so that when somebody bumps into this, they say, okay, it's red, it's vulnerable, it's the same thing as a web AP. Now what we do is we are going to filter the traffic based on a particular station that has joined the network as a TKIP station, a WPA station. And if we see the frames that it sends, if we look at the data frames that it's sending, what we're going to see is that these frames that have the frame control is 41, which means that this frame was sent from the station to the AP. These are encrypted. That's our BSSID, the source MAC address of that station. And as you can see, it's encrypted using TKIP because that's a TKIP station. And this frame was forwarded by the AP, and it was also forwarded using TKIP because it was talking to another station that was also a WPA station. So here you see all WPA traffic until we go and we set another filter that we look for web frames. We do this by looking for frames that have an IV, a web IV, and in this way we'll filter everything for web frames. And if we look at these web frames, what we're going to see is that the destinations are always either multicast destinations or broadcast destinations, and that the interesting thing is that all the frames are sent from the AP. As you can see, they have the from DS bit set, so that means that they're frames that are forwarded by the AP, and since they were broadcast frames, they're web encrypted. And in this scenario, we didn't have a web station running. It was just the AP and these two WPA stations. So now we're going to go on with what we're going to do is we're going to set the encryption key. Wireshark has the possibility of decrypting wireless traffic if you set the key. So we set the key and we enable decryption, and now we apply this configuration change. And what we see is that they are Cisco Discovery Protocol packets, which are multicast, and ARP frames, which are broadcast. So then what we do is we carry out the attack. As we said, first what we have to do is start capturing every single frame that's on the air. We do this with AeroDump. Then we perform our fake authentication so that the AP believes that we are a web station. This executed successfully. And as you see, we don't have to have any knowledge of the key in order for that to work. And then we do our attack, which is using the -W option that we added to Aircrack. And now Aircrack is just waiting to hear an ARP frame. Once it does, it will flip it as we showed before and start sending it out again. So there it happens, and as you see, the number of ARP frames are increasing in the air because Aircrack is injecting more ARP traffic. And if we look in the Wireshark capture, which is decrypting everything because we set the key, what we can do is we can look at the frames, and that's a frame that we sent. As you can see, it has the 2DS bit set. And if you look on the right column, the IP addresses are all different. That's because when we apply the mask, we don't know what the IP address is going to end up being. We just change it to something different to try to avoid IP conflicts in the network. And these are all web frames that this is the response that was sent to us by the station, and since we're a web station, the AP sent it web encrypted. And now what we're going to do is we're going to run aircrack and force it to detect the network as a web network. And what we did is that we patched it so when it did this, it completely disregards any TKIP frames so that the cryptanalysis works okay. So now it's going to start cracking. It's going to fail because it hasn't still captured enough traffic. And then we run it again. And in the meantime, it captured enough traffic to crack the web key. So there you have the web key. So basically, in the hardest scenario possible where you don't have any web stations, you can still crack the web key. Now what we're going to do is, since we looked at this and we said, okay, now we see that an AP running in this mode offers no additional security to an AP running only web. So what we started to do was to see if there was any other security features that Cisco offered in order to improve the security of this WPA migration mode. And what we found is an option called broadcast key rotation, which basically what they say is that in WPA migration mode, this feature significantly improves the security when there are no static web clients. Meaning our scenario, we only have WPA stations. So what we started to do was look to see what this broadcast key rotation did. And it basically, in the documentation, it says that what it does is that when there are no longer any web stations using the static web stations using the network, it generates a new broadcast key dynamically and sends it out to all the web stations, so so that instead of using the statically configured web key, you're using a new random key. And in order to configure this in a Cisco IP, you have to use the broadcast key change command. You specify the number of seconds that the key rotates, and you have to specify this mode capability change. So basically what happens when you're using this is what we see in this diagram. You have a WPA station, and you're exchanging frames with the AP, and everything is working okay. And then the AP chooses a new broadcast key and informs the station of this fact by performing an EAPOL frame exchange. And now all of the WPA stations have a new broadcast key set, which is the random and was picked by the AP. So then normal communications keep on going. And after a certain period of time, the key interval dies out, so you have to rotate the key, and a new key is chosen by the AP and sent to all WPA stations so that they can decrypt the broadcast traffic using this new key. And what happens when a web station joins is that it triggers an EAPOL frame exchange, but going back to the previous statically configured key so that everybody can use the same key and decrypt the traffic, as there's no way of having that informing that station of the random key. It has to go back and use the statically configured key, which is the only one that the web station knows. Then normal frame exchange occurs. And after a while, when the web station leaves, the IP is once again free to choose a random key and inform that to all the WPA stations. So basically, in order to bypass broadcast key rotation, all we have to do is tell the AP that we have joined the network as a web station and that we can't do dynamic rotation. So basically, the AP falls back to the statically configured key, and we have exactly the same scenario as before. And if we look at what we were doing, this is the first step of the scenario of our attack mode. So basically, this feature does not enhance the security at all. It doesn't change any of these facts. So in order to bypass this, we do a fake authentication with aircraft. Here I'm going to show a demo of this working. The first thing I'm going to do is set the web key in Wireshark and also set the WPA key so that Wireshark can decrypt both web and WPA traffic. Once this is enabled, I'm going to start monitoring the frames that are in the air. And I'm going to pick a filter looking for frames from our AP that are either WEP or EAPOL frame exchanges. EAPOL frame exchanges are encrypted with TKIP, so that's why I had to set the WPA key so that we could find the EAPOL frames and look at them decrypted. And what I'm going to see is that this is when the station joins and an EAPOL frame exchange occurs. This is a WPA station joining. And if we look at these are broadcast frames. They're web encrypted, but although Wireshark knows the web key, it can't decrypt the frames because these frames are encrypted with a random key that the AP chose. So if we try to crack this key, what we're going to end up cracking is a key that's only valid for a short period of time. So it's completely useless to crack that web key. So basically now what we do is we authenticate using the fake authentication. As you can see, now we are able to decrypt the broadcast traffic. Now we see that there are WLCCP frames and IGMP frames, and that an EAPOL frame exchange had occurred before in the capture, and that was telling the WPA station that was in the network what the new key was, which was the statically configured key. These are just analyzing the frames. So basically what I'm going to do now is deauthenticate myself. So now I have deauthenticated, and the AP will once again perform an EAPOL frame exchange with the access with the WPA station, and once again broadcast traffic. We're not able to decrypt it even though it has web because it chose a new dynamic key. But this is how it works, but it's trivial to bypass because I can just fake being on web station, and this feature gets magically disabled. So we said, okay, let's see if we can find another scenario, different ways to mitigate our attacks. And one typical thing that people enable in web, if they have to have a web AP hanging around because they have, I don't know, some hardware that's not able to use WPA, is that they enable PSPF. What PSPF does is that it is not allowed station-to-station traffic. Basically, on the diagram on the left, you have two stations. They can talk to each other because no PSPF is enabled. In the second case, when you try to send a frame from one station to the other, the AP drops that frame and says, this cannot be used. This feature was introduced by Cisco mainly to be used in hotspots, so that all the broadcast net bias and all that stuff that everybody would be shooting around went dead. And this has the advantage that if you enable this in a web network, there are certain attacks that you can't carry out. For example, the chop-chop attack doesn't work because you need the AP to forward frames to another station, and you have to go through the AP. So basically what this does is that this forces you to use some other types of attacks against a web network if it's configured with PSPF. And the only attack that you can carry out in this is if you have PSPF enabled on a web AP is to attack a station directly. Because if you try to go through the AP, it will never send the traffic forward. So basically you have to go through the attack directly a web station so that it generates new and more broadcast traffic, new web traffic that you can use to decrypt the key, to crack the key. So we said, okay, we don't have any web stations to attack because we're assuming that we're in migration mode and there are no web stations in sight. So this might be a security feature that does enable us to thwart our attacks in migration mode. Basically, what you see below is how to configure this in a Cisco IP. You have to use the port protected option. So we started thinking, okay, how are we going to manage to crack the web key under this scenario where we don't have any web stations, so we can't attack them. We have PSPF enabled, so the AP won't forward our traffic. So we started to look what the station did once we joined the network, what happened. And what we noticed is that each time that a station joined the network, in particular a web station, but the same happens for WPA stations, Cisco IP starts throwing around a lot of broadcast packets, which are web encrypted because they're broadcast. And if we decrypt them, we see that these are IGMP packets and WLCCP packets. WLCCP packets are Cisco's wireless LAN context control protocol, which is a protocol that Cisco uses to coordinate the APs, the access points. So each time the station connects, either a web station or a WPA station, Cisco starts sending out these frames by default. And the interesting thing is that WLCCP frames have a lot of the packet. You know it beforehand. As you can see, they're all fixed values. And the only thing that changes between them for this type of WLCCP frames is this destination and source MAC address, that even though it's encrypted inside the frame, we also have it in the header, the 802.11 header of the packet, which is plain text, so we can see it. So basically, we can know the plain text of the packet without having to decrypt it. So this gives us certain possibilities for cryptanalysis. So what we did was we came up with this attack that what we do is we authenticate as a web station without having to have any knowledge of the key, and we continuously send reassociation requests to the Cisco IP. And what the Cisco IP does is continuously send WLCCP packets back to us, which are web encrypted. So we then capture these frames, and using these frames, we crack the web key. The problem that this has is that Aircrack does not know how to do cryptanalysis on WLCCP frames. You only have to go back to the FMS mode, attack mode, and the FMS attack mode requires over 500,000 packets in the best case, and normally it takes up to 2 million frames for it to succeed. And the problem was that this attack was very, very slow, so capturing 2 million frames would be impossible. So what we did is we patched Aircrack so that the PTW attack, which is this attack that came out in 2007, which does a different type of cryptanalysis on web, and is able to crack the web key using a mode with a good chance with 80,000 packets, which is a lot lower. So we added to Aircrack the logic to find WLCCP packets based on their size, and because since they're web encapsulated, one of the few parameters we have are their size. And we added to the Aircrack the possibility of doing the cryptanalysis on these packets. As I said, the first bytes are fixed of these packets, so we know them beforehand. So we added this information to Aircrack so that the cryptanalysis could succeed here. And the only thing that was unknown was that we have certain bytes inside the frame that are the MAC address of the sender, but we can take that information from the header, so we know it, even though it's something different from frame to frame. We know it because we have it in the 802.11 header, which is plain text. So we added this to Aircrack so that we could perform this attack. So here we're going to run the attack. We're just capturing traffic from the IP. Here we have Kismet once more showing the IP. Nothing new under the sun here. Then we set the same filter as before to capture all web traffic. If we apply this filter, we're going to see the same as we did before. Now we start capturing with air dump all the traffic for the BSS ID, and we perform this fake authentication. And this -Q option is something that we added to Aircrack so that it would flood the AP with reassociation requests. And if we go back to the capture, you can see that the AP is sending frames all the time, which are web encrypted. They're being sent by the AP. That's why it has the from DS bit set. And the source address is that of the wired side of the AP, the wired MAC address of the AP. And it's a web frame. And if we set as before the web key, what we're going to see is that they're all WLCCP frames. We have the web key set. We enable decryption. And now you see that they're all WLCCP frames. Now what we're going to do is, okay, same as before. They're the same frames. Now it's just them decrypted. And we're flooding the AP with this. We also added some capability of lowering this attack so that it doesn't flood it like that, but we just wanted it to crack fast, so we left it flooding. And if we try to crack the web key, as we can see in all this time that it was capturing, it captured less than 900 IVs, which is very, very little. We need at least 80,000 for this to work. And it's going very slowly, even though we're flooding the AP, because the attack by its nature is slow. So that's why we had to patch the cryptanalysis, because if we had done the FMS, we'd have been there for ages. So this was about roughly 30 minutes, 45 minutes later. At that point, we had 60,000 IVs, and Aircrack was able to crack the web key. All these patches to Aircrack that I'm mentioning are going to be put up in our site. They can be applied to the latest version of Aircrack to add all these new capabilities. So basically, as a recap, this is the standard web clacking flowchart to attack a web AP. The interesting thing is that this new attack mode can also be used against a Cisco AP if it's just running web. So basically, we add that new branch of a new attack mode. And this summarizes our WPA migration mode attack. The flowchart, this is what I've been talking about. And basically, we always conclude in cracking the web key. So no matter what types of protection we try to add to the AP, we were also always able to successfully crack the web key. And once we have the web key, we can access the network. There's only one tiny detail to this, that if you remember when Diego talked about how to configure WPA migration mode, he said that you have to put the key in slot 2 or 3, which is what normally everybody uses the first slot, slot 0. So if you look at the web frames that are in the air, you're going to see that they have a key index of 1 or 2. And so if you try to join this AP using web, you're going to have to, in Linux, specify the key ID in the iwconfig command, or in Windows, you have to add the network and then manually by hand go to the advanced options to set the correct key index, because if not, even though you have the correct web key, you're not going to be able to join the network. So now Diego will talk about some mitigations and recommendations.
So now we know that an AP running in migration mode can be attacked and the web key can be obtained from there. So basically, solutions. So we know that web is completely broken, so you should avoid it and do not use web. This is a basic solution for that. And turn off WPA migration mode if you are finished with the migration process. If your web station are not there anymore, turn off this option, because as Leandro showed, the web key can be cracked and an attacker can be able to connect to the AP to then attack the rest of the stations. Some mitigation strategies. So enable PSPF, station isolation. As you have seen, it can be cracked anyway, but it is a mitigation strategy. Enable MAC filtering in order to try to limit the attack surface. We all know that cloning a MAC address is something that is easy to do. Limit the signal strength in order to cover your operations area, your building, wherever, and implement some time-based filter in order to just put some access control to the whole infrastructure. So under these conditions, don't forget that the attack is still possible. So these are mitigations, but the attack can be carried out anyway. And some recommendations. Try to split your AP using two service set two different service set identifiers, one for WPA and the other one for web. So you can put all the filtering and all the access control you need between those VLANs. This is much more secure than the first option, which is the one SSID using both encryptions. If you can use VPN over the web part of your network, which is interesting, which is an interesting solution, but it depends on the devices or endpoints or computers you are using in the web part of your network. And finally, some general recommendations about how to secure a wireless network can be found in the integrated deployments of Cisco Wireless LAN Security. And then you have a Google Books URL to look at this book. If you have some questions, please let us know, and we can try to answer.
Are you going to take a microphone? Yeah. I didn't hear your second question. The first question, the answer to the first question is no. You have to explicitly set WPA migration mode. And what was your second question? Yeah, you have to manually set it if you're going to use WPA migration mode, because migration mode supports static web clients, and in order for the AP to have that key, you have to manually set it. There are some types of attacks that you could carry out. We did not focus on that. There might be some possible ways, but the thing is that since you already have the web key and you can connect to the network, obtaining the WPA key is not going to give you any additional information. So we didn't go down that road. Sorry? Yeah, but once you know the web key and you connect with that web key, you're going to see everything. You're not going to see the TKIP traffic because that's WPA encrypted, but it doesn't matter. You can still attack the stations and the network from a layer 3 perspective. So it wasn't the focus of our research. Okay. No more questions?
Thank you.
Thank you.
All right.